So hi guys, today we'll be starting with triangles. Um, but first and foremost, let's begin with polygons, which is the broader term for these two-dimensional geometrical shapes that we observe around us. But the question is that is every two-dimensional shape a polygon? Let's say, is this a polygon? Or let's say, is this a polygon? Or is this a polygon? Which one is it? So, as per the definition, a polygon is a two-dimensional geometrical shape with a finite number of straight line segments connected to form a closed polygon chain. So, finite number of line segments form a polygon, and typically there are two things that are important to a polygon, that is the vertices, these vertices, and the sides. There is another two-dimensional geometrical shape that is equally, if not more important than the polygons that we'll be going to discuss so far, is the circle. Now, in a circle, you would observe that there is not a fixed number of line segments. Then, can we classify it as a polygon? Well, typically you would observe that you start with a simple polygon. Let's say the most basic polygon is a triangle, or the first polygon is a triangle with the number of sides as 3. Now, as you keep on increasing the number of sides, you would observe that let's say n is equal to 8. So that is an octagon. So you observe that it starts slowly converging into a circle. So in a way you can say that a circle is a polygon with infinite number of sides, and that's what gives it the continuity. Anyways, that's not relevant. Let's move on to the topic of discussion, or even before, let me leave you with a question. Say that there's a polygon with k sides, or rather with k vertices. Such that, although it's obvious, but for the sake of more to make things simpler, I'll say that the k points are non-collinear. That is, they don't lie on the same straight line. Express the number of diagonals in terms of k. So try to find the answer by taking cases for k is equal to 3, 4, and so on. The answer can be easily determined by using a higher mathematical a mathematics concept of permutation and combination, but try to find patterns of it. I'll discuss the answer at the end of the video perhaps. However, let's move on to the topic of the day, that is triangles. So triangles is the most basic polygon. You can't have a polygon with n less than 3, right? There you can't have a closed geometrical shape wherein the number of sides is less than 3, the number of points is less than 3. Hence triangle makes up for the first polygon, and often very extensively discussed and observed since ancient times. The Greeks were famous for their findings on triangles itself. Anyways, the characteristics of a triangle is that it has three vertices. Second, it has 3 sides. And third of all, the sum of interior angles is 180 degrees or pi radians. Okay. Now, before we move on, I want to differentiate between radians and degrees. So actually, just like you can measure a cloth in centimeters, meters, well, centimeters and meters are part of the same decimal system. But let's say you might have heard that in England or in United States, they measure weight in pounds, while the metric system, they use kgs to measure weight. So radians and degrees are two ways to measure angles. Angles is basically the degree of rotation from a line segment or one ray to another. So this is a degree of rotation. Angles are nothing but degree of rotation. So this x can be denoted as x degrees, or let's say y radians. Obviously, because we are using a different system to denote the degree of rotation, hence they would be of different value. So that's the primary difference between degrees and radians, and for the at least at this point of time, you should know that 180 degrees is equal to pi radians. Now the question is that how can you denote, let's say 30 degrees, or let's say 60 degrees, or let's say 90 degrees. So I would urge you to pause the video for a minute and try to find these answers. Okay, so we will be using simple ratios and proportion. What I mean by that is, say we know that 180 degree is to pi is to 30 is to x. Let's say this value be k. Hence 180 by pi is equal to 30 by k, or 36, we cancel it out, k becomes pi by 6. Similarly, when you calculate 60 degree, it will be pi by 3, and 90 degree will be pi by 2. Now I have specifically chosen these angles because they are very common when we are discussing triangles. So what is important to you from this discussion is that first of all, that pi radians is equal to 180 degrees. Often you'll observe that I'll forget to write this C or this notation for radians. I'll just simply write 180 is equal to pi. So apologize in case I do that in the future, but this is the correct way to denote radians. Then we have 90 degrees as pi by 2, 60 degrees as pi by 3, and 30 degrees as pi by 6. Okay, now let's my god, anyways now there's some basic terminologies that is specific to triangles. So you have let's say this triangle has 3 angles, or let's first begin with the vertices. This is typically denoted as ABC. So whenever you are told that, let's say, a triangle ABC, you should always draw this image, because why is it important? I'll tell you. The side opposite to the angle A is typically denoted as small a. The side opposite to angle B similarly will be denoted as small b, and the side opposite to small c, angle C, is denoted as small c, right? So as a summary, BC is equal to A, AC is equal to B, and AB is equal to C, right? So, and whenever I will denote an angle, I'll just simply use A. Let's say A. A is this angle. Rather than saying angle BAC, I'll just simply write A, right? So the sum of the 3 angles is 180 degrees. So what I'll write it as, A plus B plus C is equal to 180 degrees, which is also pi radians. And the sides is denoted as ABC. We define a thing called S, that is semi-perimeter, as A plus B plus C by 2. Why is it important? Because there is a formula which is called as Heron's formula, and you can when you evaluate the area of the triangle using the sides, you use this semi-perimeter for the same. So the S, or the semi-perimeter, is simply sum of the sides by 2, half the perimeter. So that will be all for this video.